So let's finish our review sheet, and then I have a bunch of papers I want to hand back to you. But let's do our review sheet, make sure we get it done. So remember your test. 2 parts, calculator, no calculator, and we are we're on the, we just started this review sheet. We're on the one called Precal A Review 26 to 28, it's page 5 of the packet. And we did number 3 already. Number 3 is the one we did. Now we're going to do the rest of them, and all the ones above the line there, 1 through 6, are no calculator. So we need to be able to do all of this with no calculator. We already did number 3. So the first question says, find the domain of this. Okay, so this kind of is a little bit of a review question, but it's hugely important, especially in terms of like extraneous roots and stuff like that. Domain is what can X be? What can X be? I usually think about it first as what can X not be? Is there anything in this problem that X can't be? Well, there's a denominator, and denominators cause me issues, right? Because I know that x squared minus 2 cannot be 0, which means x squared cannot be 2, and x cannot be plus or minus the square root of 2. So you don't need to know what root 2 and negative root 2 are, but root 2 is over here and negative root 2 is over here, right? And x can't be those 2 things. So the domain is, what can x be? Well, it can be all of this. So negative infinity to negative root 2. It can be all of this. So negative root 2 to root 2. And it can be all of that. So in other words, it can be everything except root 2 and negative root 2, right? So I would have to write it out like that, but it's basically just the whole number line with those 2 openings in it. Is that okay? All right. Find the zeros. Okay. All right. Good practice. Find the zeros. How do I do that? Well, grouping, grouping would be a great thing to think about. But after you look at it for a minute, you see it doesn't group. So we're going to start guessing some numbers, and they would be factors of 20 over 2. Yeah. So what do you want to try?
Negative 4.
Negative 4. I don't think negative 4 is going to work.
Negative 2.
Negative 2.
5. Positive 4. 5.
You're going to do one at a time. So 4.
Yep, there we go.
Oh, there we go. There we go. There we go. So, remember, I'm finding the roots. This isn't an inequality. It could be, but it's not. So one of my answers is 4.
2x squared plus 7x.
The other 2 are going to come from this. actually, I think that factors. Now, could we use the quadratic formula though?
Yeah.
Always, always. But I
Safe
think
bet.
that factors 2x, oh, maybe not.
Yeah, it does.
2x, x, 5 and 1.
Yep.
So my other two answers would be -1 and -5/2. Is that okay with everybody? I'm gonna skip the next one because it's just like that one, only it's even bigger. Let's just do C. We gotta get it through this sheet. So here we go. Now be careful with this. Don't try to do this. That isn't going to work. Did you notice that's a cube? So don't try to do that. Also, don't try to use the quadratic formula. Don't say, oh, A is 1, B is 6, C is negative. No, it's not quadratic. So we're going to do what we just did. Only looking at it, I can see that 1 works, so I'm going to go ahead and divide out 1. When I divide, though, I got to be really careful because something's missing in there. Do you see that? What's the matter, Nathan?
The x plus 1,
Mm-hmm.
negative 1, what was it?
Where does that come from?
Oh, when it packed.
Yeah. This right here.
Yeah, yeah, yeah.
All right, everybody with me that I gotta put a 0 in this division?
Yeah.
All right, so I think this works.
For one.
So one of my answers is 1. Now this time I am going to need the quadratic formula. That's now quadratic. So let's run through that to make sure everybody's got that under control. X equals negative b plus or minus the square root of b squared. Uh-oh. I think we're gonna be imaginary, that's okay. -1 plus or minus I root what? What does this work out to be?
27.
-27. So I root 27. Everybody keeping up? And then 27 breaks down. 3 root 3. And there it is. That goes with my 1. So my answers are 1 and those.
You put the I before the B, right?
Yep. Okay, we are all set there, guys? Everybody okay with that? My job is to stand up here and blab, your job is to ask. Right? That's your job. Okay, find all the asymptotes and intercepts. So we don't have to graph the whole thing. We just have to find the asymptotes and intercepts. So we're gonna have vertical asymptote, we're gonna have end behavior asymptote, which can be horizontal or slant. We're gonna have an x-intercept and a y-intercept. Okay? Vertical is x equals -2. Remember, asymptotes are equations. These guys are going to be points. But the asymptotes are equations. So to find our slant asymptote, does everybody recognize slant? If it had been x squared over x squared, it would be horizontal, y equals 1. But since it's not, we'll have to divide. So what is my slant asymptote? Y equals, always an equation, y equals x minus 5.
You're just asking the question.
We're all good here?
Yeah.
Everybody follow? Okay. Now, to find my y-intercept, I'm going to plug in 0. So what happens if I plug in 0?
You get 5 over 2.
5 over 2, 2.5, 5 halves, however you want to write that. Is that good? Now, how do I find my x-intercept again?
Plug in 1.
Numerator. Yeah, so technically, Dana, you're right. I let this be 0, but when I multiply, I'm going to solve that now. This just disappears because that's a 0. So I end up solving that equation. The numerator equals 0. That does not factor. Negative b plus or minus square root of b squared minus 4ac, there aren't any. How do I know there aren't any x-intercepts?
It's a negative.
That's going to turn out to be imaginary. So when you are talking about x-intercepts, you're talking about points you're going to put on the x-axis, right? And if they're imaginary, there are going to be no points on the x-axis. So whatever that thing looks like, it doesn't touch the x-axis. Any question about that? All right, now we're going to solve an equation.
There's an I. Oh.
I want everybody really paying attention. I know it's Friday, big game day. I know I'm boring as heck, but I didn't teach academic last year, so I really can't remember. But the people who taught academic last year said this test was a disaster. So I just want to make sure we're prepared, and that means you got to be paying attention. All right, how do we solve this?
How are you evaluating this?
Yep, and my common denominator,
X minus 2 equals 2.
um,
Oh, wait, no, X squared times
did I
X minus
copy it right?
Yeah, you're wrong.
2 instead of.
Okay, so, oh wait, that's not part of the problem. Okay, so the common denominator is going to be 2, x minus 2. Does that make sense to everybody? As soon as all the denominators match, then I can just bag them. And I look at my numerators. 4x squared plus 2x equals 20, be careful with this one, minus 5x plus 10.
You just cancel out the
Denominators are gone.
So I know. So when we cancel, or when we make all the denominators equal, can we cancel it out?
Yep.
Okay.
In an equation,
Yeah.
not in an
Oh,
inequality.
got to
Not in an inequality, but in an equation, yeah. In an equals problem.
Is it a graph you need to set? Graph you separately? Trying to find 0?
This is a no calculator,
Okay.
so we're gonna get this all set equal to 0. So I'm gonna add my 5x over, and that's gonna be 30 minus 30. got factors or not?
I think 4x, 4x plus 15, and x minus 2.
Whoa.
Oh, that was our
You're a
number.
good factor.
There.
Nice.
Okay, now, me, without Jack's help, I'd still be messing around with this, and I probably would give up and go to the quadratic formula, but I'm gonna get the same answers no matter what. So, he's gonna factor, because he's obviously really good at it. If you're not so good at it, then you can always use the quadratic formula, right? And even though this is on the no calculator part, I'll probably give you a little calculator so to help you with any arithmetic issues. Anyhow, using what Jack said, what are my answers? X equals negative 15 fourths and x equals 2. Woo! Can x be 2?
No.
No way, Jose. So the only answer to the problem is negative 15 fourths. If you are concerned that you'll miss that'll get right by you, in the very beginning of the problem, before I did anything, could I have said x cannot be 2?
Yeah.
And that's not a bad idea. That's called an excluded value. So before I did anything, I could look at the problem and say, I don't know what x is, but it can't be 2.
That's the only thing you can.
That's the only thing it can't be in this problem. List all the discontinuities and intercepts. Okay, so this is another one, kind of like over here. So we've got okay, so this is another one where we don't have to physically graph it, but we still have to find all the discontinuities. So that would mean we need to find the horizontal asymptote, or I'll call it end behavior. Could be, in this problem, it'll be horizontal. We need to find our vertical asymptote. And then we need our we need holes. If we have a hole, we need to find it. And then x-intercept and y-intercept. So basically, they're asking me for all that stuff. I don't need to graph it unless you want to. So what do you notice? I factored everything. Did you take a 2 out of the top and then factor? Okay, keep the 2.
Horizontal.
So those are gonna be gone. So this is basically what I have left. So what do you know? We can fill in anything here. What do we know? Our horizontal asymptote.
Y equals 2.
Y equals 2.
Or vertical is x equals 2.
Does everybody understand why this time it's horizontal? Because it was x over x, or x squared over x squared in the original. Where's my vertical?
Negative 3.
X equals negative 3.
You got a hole.
I am gonna have a hole because I was able to
Cross it.
cancel. And the hole will be
1/3.
3, comma, put in 3.
2/3.
I get 2 times 2 over 6.
Wait, 2. 1/3. No, 2/3.
2/3. I put in 3. What's my y-intercept? I don't know, put in 0. What do you get when you put in 0?
2.
Negative 2 over 3, very good.
And then 1.
And if you set that equal to 0, you get 1. So this one does have an X intercept and it's at 1. Okay, one more time. My job is to be up here rattling on. Your job is to ask. Who has a question about something here? 2x over x, I box them in.
If you just multiply it out, I just thought 2 over x.
X over x. Yes, and go back to the original, 2x squared over x squared. All right, now we're gonna get our calculator out. Here we go. Need our calculator. Okay, is problem 7 a mixture problem?
Yes, it is.
Usually, in fact, I mean, every one we've done, our mixtures have been a percent solution and another percent solution. This time, instead of percentages, we have money. Yeah, but it works the same way. So we're gonna have amount times, not percent, but price, plus amount times price equals amount times price. Okay, so here we go. So throwing it in. So Maddie wishes to make 20 pounds of a candy mixture that costs $3.60 per pound. To do this, she's going to mix 2 types of candy. One type costs $2.50, and the other type costs $4. And she wants to end up with what? What does she want to end up with? 20 pounds of $3.60.
And 20 minus
So I don't have any idea what either one of these are. So I'm gonna call one of them X. Only one of them can be X. The other one will be,
minus 20.
no,
Y.
20 minus X. Total minus. Charlie, which one's bigger? Is X bigger or is 20 bigger?
20's bigger.
Yeah, so it's gotta be 20 minus X, right? If that confuses you, call this Y for just a moment. Call that Y. X plus Y has to be 20. Would you agree with that? So if X plus Y has to be 20, what is Y? 20 minus X. That's why we have a 20 minus X in there. All right, let's solve it. Everybody solve it. You got a calculator. Okay, I did a lot of that without my calculator, so it could be full of mistakes. I don't know. Oh, yeah, I do. Oh, yeah, I do. Anybody else get 5 1/3 and 14 2/3
Yep.
pounds? Okay, were you able to make that transfer from your percents to your price, okay? It's the same situation.
Don't change anything. Don't change anything.
No, you leave the price alone, yeah. Okay, John can take the test in 3 hours. If Mary helps him, They can get it done in 2 hours. How long does it take Mary to do it alone? What's our setup for this? 1 over John plus 1 over Mary equals 1 over together. Does the position of all those numbers make sense to you? Do you think I got them in the right spots? X is Mary's time alone.
So 6x.
Common denominator would be 6x. So again, I'm gonna make all my denominators the same and then ditch them. And it looks like Mary's gonna take 6 hours if my math is right.
Looks good.
All right. All right, so my equation is 120 minus 500 over x plus 8. X equals 0 is 1990. X equals 1 is 1991, okay. Find the amount of sales in 2011. So what would X be if it's 2011?
21. No, it's 20.
21.
21. 10. Yeah, it's 21.
Okay, add 1 to get 1991. What do I add to get 2011? 21?
What's that?
That math correct? Okay. So all I do now is go to my equation and plug in 21. So 120 minus 500 divided by 29.
Yep.
You get 102.8.
Yeah.
And is there a unit on that? Oh, that's dollars. 120.8, or so, $120.76. Everybody okay? All right, Pat sells soccer socks. He needs to sell them for $5.75. So, the price is $5.75. It costs him $4.16 to produce. Overhead is $3,850. How many pairs of socks must he sell to pay to have $10,800? So in other words, he wants his profit to be $10,800. Is that how you interpret it?
It's like inequality.
And how do we find profit?
Amount
Income,
times
So mine.
income, number sold,
Mine.
income minus cost.
Oh.
So income minus cost has to be $10,800. Now, what's his income? How is he making money?
Selling
He's
socks.
selling socks.
Dirty.
And he's selling them for $5.75 a pair. So his income is $5.75x. We'll let X be the number of pairs of socks. So every pair of socks, he gets $5.75 for.
Plus.
Okay, now, what are his costs?
416.
His costs are in two parts, you guys. every pair of socks he makes costs him $4.16,
Minus X.
Five
right?
plus 3.
$4.16 per pair. But he also has to pay the light bill, pay his taxes, pay all of those things that he has to pay whether he makes socks or not,
Yeah.
right? Doesn't matter, he gotta pay his bills,
No, plus.
right?
It's
So,
Yeah, plus.
this is gonna be plus another $38.50. Now, both of those are gonna be subtracted. This is the total cost right here. So we have 575X minus 416X minus 3850 has to equal 10.8. So 159X equals 14,650. He's gonna make a lot of socks. 9,214 pairs. Hey, remember, what's your job? Ask. Don't just sit there and passively write it down. Because I'm not working it out for you on the test. You need to follow what's happening here.
Why do you have to distribute the negative?
Because you are, this, your cost is both of these. That is your whole cost. So you have to subtract the whole cost. It just so happens it's in two parts. Okay? Sam is going to box up the socks. Oh, this must be Samantha. Her box must have a volume of no more than 100 cubic centimeters. Squares are cut out, what size corners should be cut out? Okay, so this is our box. Make sure you understand what's happening. The paper is 11 by 16. So, what is the equation for our volume?
11
11 minus 2x,
16 minus 2.
16 minus 2x,
Times X.
This time, we want the volume to be no more than 100. That means, whatever that is, it has to be less than or equal to 100. So I can go right to my calculator. Now, before you do this though, what is your domain? What is your x
8,
window?
0 to 8.
0, not 8.
Oh, 1 half.
5.5. Now that is gonna be critical in this problem, you guys. You gotta understand x has to be between 0 and 5.5. So whatever answers you come up with, you gotta be in there.
It's the first
So
number.
don't be saying 7.
It's the first number, not
It's
the
like if
second.
it was 16.
Yeah, it's the smallest number in the equation.
Oh, the smallest number. That's the
You
biggest.
have to take this out.
Okay,
Take the other one.
so that, before I even put my equations in, I'm putting that in. Now, y min will be 0, and y max, we're only going up to 100. So I'm gonna make it like 120, just so I have a little bit of room at the top. And then one of my equations is this, type it in with the parentheses.
Always having 100.
And the other equation will just be 100. And I don't want you to be alarmed you're gonna see something that looks like this, right? And you don't even see that, or I don't see that. But I don't care, because remember, I wanna be
Less than 100.
less than 100. So my answer is going to be this right here, and this right here, right? So I'm gonna find those points. So second calc intersect. I'm gonna find those 2 points. .718. Tell me if you got something different. And 3.937.
It's not infinity, but
Talking about, you're right.
so find zero.
Okay. So, we doing okay with this, folks? Now, what is our answer then?
0.
0.718
Union.
in union with
3.9375.
3.937, 5.5,
Oh, 5.5.
right?
Yeah.
It's gotta stop at 5.5 because that's where your domain stopped, right? So this would be the answer to the question. If we wanted to be more than 100, then we would do between those, right? Are we good? All right, number 11.
It's the smallest number, that's the domain.
Or that was 11, now we're doing 12.
So
You gotta get a common denominator.
common
Or you can do multiple ways.
What?
Do multiple ways.
You can do this multiple ways. Now, here's the scoop, folks. If you get a common denominator, this is gonna become a cubic equation, right? So, and that's perfectly okay. But, remember, you're not gonna, if you're gonna do it by hand, you do a PRs and all that, but we have a calculator. So, could we graph each side and look where they intersect? Or, could we move it over and look where it crosses the x-axis, find the zeros, in other words? Doesn't matter. So do it, however you wanna do it. Remember, your window is screwed up from the last problem, no? So, just keep that in mind.
Plug in,
I got negative 2.803, basically.
Yeah. Well, yeah.
So if you got that, then you are fine. If you didn't get that, then you're wrong. I did this. This is how I did it. So my picture looked like that, and I was looking for the x-intercept. Did anybody graph them separately and do the intersection? No? Okay, it's up to you completely.
And if we have like a question like this on the test, we'll have a calculator for it.
Everything from 7 on is calculated.
Gotcha.
Okay? the other side of that page. So in other words, it's the back of the last page of your little packet. And most of this we've already talked about, but I want to draw your attention to problem 5D. 5D. Okay, 5D, everybody there? 5D? The math department wants to minimize the amount of poster board needed for the next math lesson. The department is committed to having 144 square inches of print material. So this is 144 square inches of printing in here. Surrounded by borders on the left of 1.4, on the top 2, and 1.75 on the bottom and right. So whatever it looks like, there's gonna be some writing in the middle, and then there's these borders around it. What is the minimum area for the poster? We did one of these the other day.
What size is the other board?
Area will be length times width, right? So what is the length all the way across here?
X plus
3.15
Well,
plus
if I
X.
call this x, which I can, that would be x plus 1.4 and 1.75.
So, yeah,
What is it?
3.15.
3.15, so x plus 3.15. Everybody with me here? Now, here's where you gotta put your thinking cap on. Now I need this.
Yep.
Well, this is gonna be that plus 3.75. The problem is, what's that?
X minus
Y.
Can't have two x's.
It's gotta be it's something minus X. It's that.
Okay,
Seven
wait a
point
second.
two.
For a moment, let's call this y.
Minus X.
For a moment, let's call it y.
For height.
X times y
Oh,
is
14.4
144.
divided by X.
144
Or 144 divided by X.
No. 144
Guys,
over X.
X times y is 144. They tell me that in the problem. So that means y is 144 over x. So this is 144 over x plus 3.75.
Wait, can you explain that again, please? Can you explain that again?
I know that the area of that rectangle is 144. X times y has to be 144. That means y is 144 divided by x.
Yeah, got it.
I really don't want to have two variables in my problem because I'm going to go to my calculator and I can only do one. And what I want to do, minimize. So you don't need to distribute. You can if you want, but the question says find the minimum area. So if I graph this, what would I be looking for?
Minimum.
The low point, right, the low point. So let's give it a shot. You can distribute if you want, but you also can just type it in like that.
You got them together, so.
This is all one thing. You're graphing that and looking for its minimum. picture, I'm trying to get it to go.
No, I got a picture too, but it's like a negative infinity.
That's what I'm trying to see if it's ever gonna go back up again.
It's not even loading.
What?
Like I want the negative 10,000, it's not even loading.
Oh, yeah. Okay, you went, yeah, you got it.
Oh, it just stops.
Oh my god, yeah. exactly.
No, it didn't stop.
Maybe it's just a website.
I'm getting my Nike swoosh.
Yeah.
There we go. Okay, so a window that gives me a really good picture is 0 to 100 on the X's and 0 to 1500 on the Y's. Try that if you haven't gotten a picture yet. And you'll see a definite minimum. This kind of question was on one of the other reviews. Might be worth knowing how to do. For my minimum, I got 10.998. What was the question?
You gotta plug it in, I think.
Oh, now I gotta plug it in. Oh, no, I don't. My calculator did it. It'd be 238.299 square inches. There's your area. Y is your area. 238.299.
Wait, where did you get the 10.998?
That was my X. That's the X coordinate. That's what I got for the X coordinate.
Yeah.
He's struggling. Yeah.
So make sure, Sam, you typed in the equation correctly, use that as your window, and you should be able to find your values. Okay?
Wait, Y100 and
Y, these are X's, X min, X max, Y min, Y max. One more thing, in our last couple minutes here, number 4A, what are the excluded values?
It's 0 and -4.
0 and -4, thank you, Dana. He factors the denominator, and from the factors, he can tell X can't be 0 or -4. What about B?
-3.
I squared 3.
Oh, it caught me. It's 3 root 3.
None. The denominator in number B can never be 0.
Imaginary.
Right? And then what about C?
See?
Excluded value.
Which X gives 0.
X can't be 0.
Good stuff.
Really? Here, that number, B.
The denominator can't be 0. X squared plus 9 will never be 0.
It has to be minus
We're gonna
9.
square and add 9. Okay, so here's how this is gonna work. On Monday, we're going to review a little bit more, because you need time to process over the weekend. Come back in on Monday and say, oh man, this is work. I need to do another like this, or I need to do another candy mixture problem or something, okay? And then we're gonna take part of the test. And then the next day, we'll take the other part of the test, okay?
We're doing the calculator now.
Huh?
What we're doing?
I don't know. I gotta go through them. I think we'll do some no calculators. I would give the whole thing Tuesday to you, but Tuesday's a short period, so we have to get some of it out of the way. Okay? I am going to return some papers to you right now. back, these are your quizzes.
Oh, my goodness. Oh, that's my second one.
I was asking for the votes yesterday.